nobody knows his name.
Okay, so the next topic is average or mean value. Okay, so mean value. All right, so what we have is f average is going to equal the following. 1 over the area of D, so the area of our domain, times the double integral over the domain of f of x, y, dA. Okay, and as we know, the area of D is equal to, so the area, I'm just going to rewrite this in a different form. So we have this part, I'm just rewriting the second part here on top, right? Because that's like a fraction, this over that. So I'll write it like that. And area of the domain is equal to the double integral when our f of x, y is 1. Remember that from the last, from the previous video? From the previous concepts video. So yeah, this is just another way to write it. Okay, so that is our average value of f when we're considering f to be f of x, y. And this is kind of similar to the one-dimensional version, if you recall, where our f average was equal to 1 over b minus a, and we had the single integral from a to b of f of x dx, right? So it's kind of the same, like dividing by our domain, okay? So remember, in one dimension, our domain goes from a to b, and in in the two-dimensional version, our domain is the actual area, like the shape in the xy plane, okay? So this leads us to the next theorem, which is the mean value theorem. Mean value theorem. Which again, like other things, you've probably seen in the one-dimensional case. So this basically says, I'll write out a little bit of it, because the conditions are important. If f of xy is continuous, so then we have continuous, so no holes basically, and D, our domain, is closed, so that means not open, basically. When they say closed, I always think of some kind of loop, where the starting point is the same as the ending point, and there's no discontinuities, right? So closed, bounded, and connected. So that just means like a continuous loop. That's just a fancy or technical way of saying it. So if this is true, then, we have our big then, there exists a point P, we're going to call it P, in D, so it's somewhere in the domain, such that the following is true, such that the double integral over the domain of f of x, y, dA, so the double integral equals our f of P, okay, so P consists of an x and y, because that's a point in the xy plane. So this is point in xy plane, and furthermore in D. Remember, it has to be in the domain. And then we have times the area of D. Okay, so this is the mean value theorem in the case of two dimensions. All right, this is the two-dimensional version of the mean value theorem. Okay, and as you can see, this is also, if you kind of rearrange things and get f of p by itself by dividing by the area on both sides, let's see what would happen. So if we divide by the area of the domain on both sides, this left side here, so these will cancel out and become a 1. This left side, this is a fraction, there's a line here, That should look familiar from the last slide, right? This is actually our average value. So f of p is our, I'll write it down here. So f of p is our average value. Okay? So that's an important connection there. Other than that, I mean, aside from problems that explicitly ask you to apply the mean value theorem, I remember when I took this course, there weren't a whole lot of problems on mean value theorem just randomly. It's just one of those things that's there, and it's good to know. Okay, now into the last topic. Okay, now for this last section here, we'll start off with drawing a quick diagram here. So let's say we have some domain D, which that was pretty bad. Hold on. So some domain D, which is connected. There we go. So this is our D, right? This whole thing is our domain. So D for domain. And then what happens here is it's just saying, so let's say we're integrating over this domain, okay, of some f of x, y, dA. This is going to be equal to, just in any case that arises, I guess, if you need to ever break this up into smaller domains, like little sections, kind of like that, or whatever, something like that, and let's say something like that, okay? And we'll label these ones, like, these are the little domains, okay? And however many you want to break them up into, you can do like infinitely many if you want, but I'm pretty sure that would be impractical and a waste of time. But anyways, and then you get to some d sub n, which could be like n equals 4, if you only want to make 4 domains, 4 mini ones. But anyways, this last thing is just saying that the thing on the left, so integrating over the entire domain, is the same as integrating over the little domains, the little subdomains. Is that a word? Okay. I'm going to declare that a word, subdomains, like subintervals, you know. So subdomains, that is a word now. Okay, so integrating over the little domains like this, so that would be just over this one here, D1, and then if you add it to when you integrate over D2, so this one, and etc., etc. So etc. is going to be denoted by dot, 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 dot. Okay, I'll do 2 ellipses, plus all the way up to D sub n, however many subdomains you create, basically. If you do all of that, then these two sides are going to be equal. So then you integrate over basically the entire thing as you're integrating over the little domains individually. Okay, if that makes sense. It's just saying that you can decompose it or break it up into parts. That's what you can do with the domain. And these will just, both sides, so the left and the right, will turn out equal. Okay? And again, I don't think, I mean, when I took this class, at least for my professor, he didn't, and also in the book, if you look in the textbook, there aren't too many problems that involve decomposing the domain. So I don't believe it's like super important, but anyways, it's good to know as well. Good to have in your toolbox, so to speak. So anyways, that does it for the section on double integrals over more general regions. And I think that the big takeaways, the most important parts, are remembering the characteristics and how to solve problems involving vertically and horizontally simple domains. Okay, those are pretty important, and they will come up later in the course. Okay, so again, good luck on homework, and I hope this video helped, and I'll speak to you in the next video when I do problems from this section, if you care to watch.
I know his name, I didn't know his name. All night long.